Welcome to this presentation on landslide risk assessment. Today we will explore the key methods and tools used in effective urban planning, specifically focusing on how engineering geology supports safer urban infrastructure. Let's get started. This presentation focuses on landslide risk assessment in urban infrastructure development. We will discuss how geological mapping, modern geotechnical tools, case studies of successful mitigation strategies, and sustainable design principles play a wider role in creating resilient urban environment. Landslide risk refers to the potential for landslides that can damage infrastructure and cause fatalities. Understanding these risks is crucial as urban expansion often occurs in vulnerable areas. Factors like geology, rainfall, and human activities play significant roles. Effective risk assessment allows us mitigate damages and designs safer urban spaces. In urban development, assessing landslide risk is key for safety and sustainability. As cities grow into risk-prone areas, the likelihood of landslide increases. Effective management ensures protection of lives and infrastructure while promoting resilient urban growth. Integrating these assessments into planning helps make informed decisions for sustainable cities. There are various methods for landslide risk assessment, such as geological surveys, risk mapping, and slope stability analysis. Tools like LIDAR, remote sensing, and geotechnical investigations provide crucial data. These techniques help us understand terrain dynamics and implement proactive measures to reduce risks. Geological mapping involves field surveys, aerial photography, and satellite imagery. It helps identify soil composition, fault lines, and hydrological patterns, all of which influence landslide risks. Technologies like GIS and remote sensing enhance mapping accuracy, providing detailed insights for urban planners. Geological mapping also predicts landslides by integrating data on rainfall and human activity. This enables urban planners to develop early warning systems and targeted prevention strategies. Accurate mapping leads to better emergency response, plans, and informed decision making. Integrating geological mapping into urban planning ensures safer land use decisions. Planners can avoid high-risk zones and implement mitigation measures like retaining walls and drainage systems. This collaboration between geologists and urban planners result in safer, more sustainable communities. LIDAR technology provides high-resolution topographic data, allowing the detection of subtle terrain changes that signal slope instability. This data enables early interventions to prevent landslides, making it an essential tool in urban risk management. Remote sensing uses satellite imagery to monitor geological conditions over time. Changes in vegetation cover or surface deformation may indicate an impending landslide. Combining these data with ground surveys creates comprehensive risk assessment for sustainable development. Modern tools like LIDAR and remote sensing provide accurate, real-time data on terrain conditions. This allows for identifying risk areas, prioritizing several cities have successfully managed landslide risks. For example, San Francisco slope stabilization projects involving vegetation restoration and drainage improvement have been effective. In Italy, zoning regulations and public awareness initiatives have strengthened the landslide risk management. This examines best practice for urban resilience. Past landslides, such as 1983 Thistle landslide in Utah, remained as of the importance of conscious risk assessment. In that case, inadequate monitoring led to significant damage. Learning from such events help us understand the need of integrating geological insight with infrastructure planning. Different cities adopt various approaches to landslide management. Some emphasize zoning and public engagement, while others rely on advanced technology. Analyzing these approaches helps tailor policies that address local conditions and risks, leading to more effective urban resilience strategies. Sustainable design reduces environmental impact while ensuring safety in landslide-prone areas. This includes using natural materials, promoting green infrastructure, and minimizing excavation. Reducing impervious surfaces and supporting natural drainage stabilize soil and enhance ecosystem resilience. Implementing sustainable design requires collaboration among architects, engineers, and geologists. Features like terraced landscaping, proper vegetation management, and effective stormwater system significantly reduce landslide risks while enhancing biodiversity in urban areas. Sustainable design offers long-term benefits such as increased slope stability and reduces maintenance cost. However, challenges like initial investments and educating stakeholders remain. Balancing development with sustainability ensures both safety and ecological health in urban spaces. To conclude, managing risk requires integrating geological mapping, modern geotechnical tools, and sustainable design principles. Learning from global case studies and adopting innovative technologies will help urban developers build safer, more resilient cities. Thank you for attention. Feel free to ask any questions.